Hello, it's me again, Catalin. Since I also wanted to tell you about the courses we teach at RUB, it's 3 courses. Functional programming this semester, proofs are programs next semester, and foundations of programming languages verification and security the semester after that. And this is Roberto Blanco, Clara Schneiderwind, and myself, all from MPI. The first course, Functional Programming, uses the OCaml programming language. And the main idea behind functional programming is to write computations as mathematical functions. So using recursion and immutable data types and pattern matching, and trying to limit the use of side effects such as mutating stateful data structures. This kind of programming languages, like OCaml, have had some practical success. They are used in industry, at the big tech companies for some of their projects, as well as in the financial industry and for blockchain. These kind of programming languages are not yet fully mainstream, but many of the cool ideas that were developed for functional programming are already adopted by mainstream languages. So lambdas, so these anonymous functions that can be passed as arguments, generics in Java or C#, and the type system of the Rust programming language is very much inspired by functional programming. Rust offers also lambdas, generics, data types, pattern matching, so can be seen as a functional programming language. And is also one of the most admired languages on Stack Overflow for the past 11 years. So these ideas are very cool and people love them. Functional programmers often earn more, as shown by the same Stack Overflow developer survey. And finally, functional programs are concise, elegant, and beautiful, which makes reasoning about these programs easier, both informally, where you just think about what your program does, and want to somehow make sure that it behaves as intended and doesn't have bugs, and also formally when we actually prove these kind of things with program verification. So our second course is about formal verification. It's called Proofs Are Programs, and directly builds on functional programming to provide a gentle introduction to formal verification using the Coq proof assistant. So Coq is a proof assistant based on functional programming. It has a more powerful type system, so it has dependent types that are more powerful than the usual kind of types one uses in functional programming. In particular, these types can express and prove specifications of programs, which is very helpful for program verification. When I say Coq is a proof assistant, what I mean is that Coq helps you build formal proofs interactively, step by step. So proving in Coq is very much like programming. It's lots of fun. And if you like programming, you will also like Coq proofs. And this also helps you deeply understand proofs. In fact, formal proofs in a system like Coq are just purely functional programs. And the Coq proof assistant uses this deep connection between logic and functional programming. And we are also showing it in the course. So this is why the second course is called Proofs Are Programs. And the third course is on the foundations of programming languages. So we formalize simple, imperative, and functional languages in Coq. We build type systems, simple compilers, and we also give a semantics to programs and prove meta-theoretical properties, so properties of all programs of the language. Now, we also do verification of individual programs, for instance, imperative programs in Hoare logic, or proving program equivalence and security using an extension called relational Hoare logic. And finally, we also look in more detail at security, at information flow control, for instance, how to prevent leaking secrets directly or indirectly by the control flow of the program, And we also look at side channels, in particular at how to prevent cryptographic code from leaking secrets using programming discipline called cryptographic constant time and an extension called speculative constant time that preserves security also in the face of speculation attacks. So these 3 courses are very hands-on. They're based on 4 book volumes, so there's many very good lecture notes for the course. There's also many exercises, Camel and Koch for the 2nd and 3rd course. There's automatic grading for the courses, so you get immediate feedback on your solution. And this takes gamification to the next level, and it's really lots of fun. And it will help you better understand both programming and proving. So if you find this interesting, please come to these courses. Thank you.